Hello, welcome to this lesson. Today we are covering the topics of standard deviation of grouped data. And we were covering the standard deviation from a population when we have the data from a population. And at the same time, or later in the same video, we are going to be covering what happens if we have a sample. For starting, I'm going to show you the original formula. So the formula that we're going to use to estimate initially the standard deviation when we have a population, so we are going to subtract the mean from each data, but each of the data will be the midpoint of the class. Then we square and multiply by the frequency. So this f is the frequency of the class, this x will be the midpoint of the class, and this mu will be the population mean. And when we do this product, the f multiplied by the deviation, I will say the deviation square, and divide by the total number of elements in the population, when we get the variance. After we get the square root, we are going to get the standard deviation. This will be a nice formula to use. However, when we compute the mean, because this mean, remember, is finding a division, dividing the number, the sum of all the data divided by the number of data, we get the decimal. So this subtraction is a number with decimal places, usually. When you square, the number of decimals double in the decimals, when you are using decimal numbers written in a decimal form. So for that reason, the result sometimes using this formula is not so exact. And also, you need to compute first the mean. There is another formula that I'm going to use, and it's this one, when I don't need to compute the mean. And for that reason, the decimals, it will be, we will be using, the number of decimals that we will be using is lower. So it will be, for me, it's easier to use this formula and easy to do a table that help me to use this formula. Let's make an example of how to use this formula that is apparently difficult, but it's easy to use. So we don't need to compute so many things. Say the examples, I'm going to tell you this with examples. So the examples, also I'm going to explain this using an example. So the example is the following. So we have here the formula, and here we have a variable when we have the classes. This is 5 to under 15. So every number between 5 to under 15, let's see, the number here could be 14.99, for example, is here in this class, in this interval. And the frequency is 2 for this interval, and etc. So you can see here what are the classes and what are the frequencies. If you need to compute this, the standard deviation, it will be a good idea to make some other columns for this table. For example, you will need a column for the midpoint, because in the formula appears the midpoint. You need to add together, this is the symbol of the sum of the fx, so you need a column for the fx, and you can add at the bottom. And there is here a sum of the x squared, so you can make a column for the fx squared, so the midpoint squared multiplied by f, and then add together all these numbers. So let's make 3 more columns. So one for the midpoint, one for fx, this appears in the formula, and the other for the fx squared, that also appears in the formula. This n, the capital N, is the total number of observations in the population that we know is always at the bottom. So imagine that all this is the population. This population have 25 individuals. Okay, so get the midpoint of the first interval. Remember, the midpoint is just the average between the smallest or the lowest bound of the interval and the upper bound of the interval. So 5 plus 15, 20 divided by 2 is 10. The next one, it will be 15 plus 25. You get 40 divided by 2 is 20. 25 plus 35 is 60 divided by 2 is 30. 35 plus 45. So 35 plus 45, you get 80 divided by 2, 40. And 45 plus 55 is 100 divided by 2 equal 50. So all these numbers are the midpoints of this interval. Sometimes you don't need to get the average. You notice what is the number that is exactly in the center of these two numbers. Yeah? Okay, the other column, the second column, will be for the multiplication of the f and the midpoint. So the frequency and the midpoint. You have the f in this column, the x in the second column. So the multiplication will be easy. Just see the two numbers in the row, 2 times 10. This is the frequency, this is the midpoint. This is f, this is x. 2 times 10 equal 20. Then 4 times 20 is 80. I'm going to type 80 here. 10 times 30, this is 300. I'm going to type 300 here. 5 times 40 is 200. I'm going to type 200 here. And then 4 times 50 is again 200. I'm going to type the 200 here. So, because the formula said that I need to add the sum of the fx. This is inside of the formula. The sum of the fx. So I'm going to add together all these numbers. 20 plus 80, this is 100, 400, 600, 800. So this is 800 will be the sum of the fx. And then here is fx squared. This is another number that we need to use. The sum of all the fx squared need to be done. Yeah? So I'm going to find all the product of the f multiplied by x squared. One idea is x squared. So this x squared, 10 squared is 100 and multiply by 2. So you use your calculator, 10, then square. When you square, you then multiply by 2. So the frequency times this number is square. So this is 100. When you square this number is 100. 2 times 100 is 200. So I'm sure that this is 200. This is one way to do. Another way, for me easier, is to notice that if you multiply x times fx, you get fx squared. Do you see here that if you multiply this x by this x, the algebraically this will be x squared, so it will be fx squared. So it will be a good idea if you multiply these two columns. Just multiply these two columns, for sure the answer will be fx squared. So if you multiply these two columns, it will be 10 times 20 equal 200. You see the same answer. 20 times 80, it will be 1600. Okay, 1600. 30 times 300, so it will be 9,000. So I'm gonna type 9,000. 40 times 200, it will be 8,000. 8,000. And finally, 50 times 200, this will be 10,000. So it will be 10,000. So use your calculator to make this product. Yeah? So you multiply the x and the fx, and when you do that, you get fx squared for sure. And then add together all these numbers, 200 plus 1600, it will be 1800 plus 9,000 plus 8,000 plus 10,000. And you get 28,800. So you have all the numbers for plug into the formulas. So you have this formula, so now we can use the formula. For example, here they say the sum of the x's squared. So the sum of the fx squared is here. This is the sum. The sum of the fx, this is here, 800. n is the total number of observations. Is this number 25. Let's use the formula then. Sigma equal 28,800. This is the sum of the fx squared that is here, minus the sum of the fx. The sum of the fx is 800. You need to square, yeah? This appears a square, the sum of the fx, divided by n. This number, when you divide the sum of the fx squared divided by n, this number is always smaller than this. So when you make this subtraction will be always positive. So don't worry, this is a square root that for sure you can do. Okay, so it will be this the answer. So if you do that, you get the answer of the standard deviation. But let's see, if you are going to do that in a scientific calculator, there is no problem. You just type exactly what is written here. If you are using a financial calculator or a calculator that is in mode, a financial mode, okay, you need to know the order of operation. You need to solve this part first. So 800 square first, and then divide by 25. Okay, when I square 800, I get these numbers, 640,000. And then I'm going to make the division. After you make the division is when you can make a subtraction here. Okay, let's do it. Sigma will be then 28,800 minus 25,600 divided by 25. Look at that. This number for sure is smaller than this. So when you make this division, that's what's going to happen. So this number, when you make the subtraction, the answer will be positive, and the square root will be something that you can do. There is no error there, okay? So it will be sigma 3200 divided by 25. So you make this subtraction, and this number inside is always positive. If you made the division without making the square root, just the division, this thing here is the variance. So I made the division, the answer was 128. The variance, if somebody asks me what is the variance, I will be answering this. The variance is 128. The units of the variable, in this case there is no unit, but there is a unit for the variable, dollars or whatever, it will appear here dollar squared. But when you get the square root, now the units are exactly the original units. So the square root of this is 1131, that is the standard deviation. The variance is 128, the population variance, the good estimation for the population variance is 128. And a good answer or estimation for the standard deviation is 11.31. And this is the estimation of the population standard deviation if we have the data in this group data. And I say estimation because actually this is perhaps not the real value for the standard deviation, because you don't know exactly the values. For example, these 4 values here, you don't know exactly how much were there. You don't know if there could be maybe 46, some of them 47, others 54. You don't know exactly. But you know that these are close to 50. So for that reason, this 50 is like an estimation of these 4 data is here. This midpoint is actually an estimation of the values here. So for that reason, everything that we obtain from any computation that we obtain from a table, it will be an estimation. It's not exactly the number, but it's better to have an estimation than nothing. Okay, that concludes my explanation about the population standard deviation, the estimation of that, if we have actually the population. So if we have a table that were done with the population, if the number that is here is exactly the population size. In the same way that I presented 2 different formulas for the concept of standard deviations, of population standard deviation of group data. Now we're going to see how can we estimate if we have the data from a sample, not from a population. So the formulas are similar. So if you remember, here was the x, the midpoint, minus the when we have the population. Here is the population mean. Now we have a sample, so here we are going to have a sample mean. But the main reason is that when you divide the number, the deviations square, when you divide these numbers, this sum here, you divide by n minus 1. You are not dividing by n. So obviously now we have n minus 1. N is the number of elements in the sample. So here is the formula for the standard deviation. After you get the square root, you get the standard deviation or the sample standard deviation, that it will be an estimation. So it will be an estimation of the population standard deviation. Okay, so another way to get this is a formula similar to the one that we were working with the population standard deviation. In the sample standard deviation, we are going to do something similar. And again, the only difference is that we are going to divide by n minus 1. In the other one, we divide by n here. So the rest of the formula is exactly the same. So the x will be the midpoint, f will be the frequency, and now the small n means the total number of observations in a sample or in the sample. Okay, let's see an example to understand this, how to use it. And we're going to have a sample that we used before in another video for getting other measures of dispersion, measure of locations, or measures of central tendency. So in this case, we are going to use it for computing the sample standard deviation. That was a sample, if you remember, if you saw this video, this is a sample of 60 companies, and we were researching how was the expenditure in millions of dollars, the expenditure in advertising. Okay, so let's see if we want to compute the sample standard deviation from this data in this frequency distribution. What we are going to do is make 3 columns, Max. I think 3 columns will be enough. One for the midpoint, one for the fx, the frequency multiplied by the midpoint, and another for the frequency multiplied by the midpoint square. And that's, we can do it on the right of this formula. Yeah? So here will be x, the midpoint. I'm going to type, after I get x, I can get fx. So I can multiply these two numbers, the one in f and the one in the midpoint column. And finally, we're going to get fx squared. These two columns, I need the sum of the fx, because that will be included in the formula. The sum of the fx squared will be also in the formula here. So let's get the midpoint. Between 35 and 35, you can get that the midpoint is 30. Yeah? So you can add 25 plus 35. This is 60 divided by 2, 30. So 35 plus 45 and divide by 2. 35 plus 45, this is 80 divided by 2, 40. 45 plus 55, this is 100 divided by 2, 50. 55 plus 65 give me 120 divided by 2 give me 60. 65 plus 75 is 170. Divide by 2, please, and you get 70. So you get all the midpoint. Now multiply the frequency times the midpoint. So this frequency times the midpoint. 5 times 30. I get in my calculator 150. So I type 150. 10 times 40. I get 400. 21 times 50. I get 1050. 1015. 16 times 60, use your calculator, please. So you get 960. and 8 times 70, you get 560. So you do this also when you are computing the mean. Remember, you add together all these numbers and divide by the sum of the frequency by n. Here I'm going to add all these numbers because I need it in the formula, the sum of the fx. So if I add together 150 plus 400 plus 1050 plus 960 plus 560, the answer is 3120. And now let's do the fx squared. As I told you in the previous example, you can multiply these two, x and the fx. Obviously, you multiply x and fx, the answer is fx squared, and the x will appear as square as it is here. So you can multiply this 30 times 150. 30 times 150, it will be 4,500, I guess, yeah? 4,500. Look at that, you can also square this number, use the key in your calculator, square 30 square and multiply by 5, and you get the same answer. Yeah? So again here, 40 times 400, this is 16,000. 16,000. 50 times 1,050, this is 52,500. Now 60 times 960, use your calculator for doing that. So you're using your calculator, yeah? So you get 57,600. 70 times 560, please use your calculator. 70 times 560, and you get 39,200. Add together all these numbers because this is in the formula. The formula tells me here with this symbol, I need to add together. I need to sum of this number, yeah? So this 4,500 plus 16,000 plus 52,500 plus 57,600 plus 39,200. And I got 169,800. This is what I need to use in the table, to do in the table. Now I'm ready to use my formula. The formula tells me that I need to sum the fx squared. So I need, this is done here, that I need to sum of the fx. That is done here. And I need the elements in the sample, and I know that the elements in the sample is 60. Obviously here at the bottom I'm going to divide by 59, that is 60 minus 1. Yeah? So let's put every number in the formula. So it will be 169,800 minus 3120 squared divided by 60, and everything divided by 59. So remember, do this part first, the square, and then the division. So it will be 169,800 minus 9,734,400 divided by 60. Everything divided by 59. And then I get the square root. If you do that, you make the division, and remember I told you anytime that you do that, the answer will be smaller than the other. So this subtraction here is always positive. So you make the subtraction now, and you get 7,560 divided by 59. So make now the division, and the answer is the square root of 128.14. This number inside the root is the variance. If the question is what is the variance, don't get the square root in this case. Yeah? The variance will be 128.14, and the units will be dollar, because the units here is dollar, will be, oh sorry, the units is millions of dollars. Here will be millions of dollars square, just in brackets the million of dollar, and everything is square. Yeah, so the units are horrible. Yeah, so the best thing is to get the square root, and when you get the square root of this number, the answer is 11.32 millions of dollars. Now the units is exactly as the original, and this will be the answer for the standard deviation. Yeah, this is an estimation of the sample standard deviation, that in other among other things, this is actually an estimation of the population standard deviation. So this will be the best estimation that we have so far for this sample standard deviation. But also, because we usually we want to know is what is the population standard deviation. So that will be our best estimation for that population standard deviation. So this is like a double estimation. It's an estimation from the sample standard deviation, but because the sample standard deviation is an estimation of the population standard deviation, then what we have so far in front of us is the best estimation for the population standard deviation. And this estimation is called the sample standard deviation. Okay, that concludes my explanation and finish this video. Thank you.